Okay, we're not going to cover too many different concepts today. It's really going to be one main type of calculation that goes along with our grams to moles, moles to grams. It's very similar. However, we're now going to look at solutions. Okay, so I'm actually may bring in some solutions, kind of show you guys later this week, but when we do chemistry, most of the time it's in solution. We don't just put two solids together and hope that they will mix how we want them to mix and to produce the products. Okay, so a lot of times we have to put these in solution. Okay, so far on your last exam, can anybody tell me one way that we express concentration? Okay, that's not a way to find express concentration, but you did learn the dilution equation. Okay, so that is one thing. But we talked just a little bit about solutions. So what was one of the main things that we looked at? I told you. Okay, so percent. Okay, percent by mass. That was one. Okay, but what was the other that I told you guys that we're going to use a whole lot? Molarity. Exactly. Can anybody remember what molarity is equal to? Moles over liters, exactly. So we're going to pick up from that. So I told you guys to star a slide back from the last chapter, and it's going to be the same one's going to be in here as well. Okay, we're going to be looking at molarity. Okay, and come chapter 14, we're going to look at more ways to express concentration. But today we're just going to look at a reaction, just like we've been doing for grams to moles to grams. But now we're going to be in solution. Okay, so we're going to do the same idea, except we're going to plug in molarity, okay, or we're going to be finding molarity, or we may be looking for volume, okay, because it means really nothing to a chemist if it has to be in solution if you tell me you need 2 grams. Well, I need to know the volume, what concentration do I need. To kind of give you an idea of how important concentration is, there are reactions that you can run in the lab, many reactions. It'll say, part of the procedure will say, you know, this reaction is ran at 0.30 molar, or molarity. Okay, if you even change that, you know, anywhere from, I've run a reaction that was, we tried to do it at 0.2, and it failed. It won't work. So it depends. Concentration is a factor that is, your reaction can be extremely dependent on it. Okay, so if you would think maybe, well, if I add more and more concentration, make it more concentrated, it'll work better. And that's not always the case. So if you pick up a procedure that's been published and it says 0.20 or 0.30 molar, you better do it at that concentration unless you're trying to, you know, change or tweak the conditions and you're, you know, going to see if it fails or not. But otherwise, it becomes very important. So you have to be able to. So when I would go to my lab notebook, I kept a notebook, just like you guys are kind of keeping a report sheet. And I had to calculate every time before every reaction the same things that you guys are calculating. I'd calculate a theoretical yield. I'd calculate my percentage yield. I'd calculate the molarity, or how many grams I would need to use before I start a reaction. So this chemistry, these calculations are used time in and time out. Doesn't matter if it's the Nobel Prize chemist, well, maybe he doesn't do much in the lab anymore, but his assistants do. And every day they're doing these calculations, you know, time in and time out. Okay, section 3.8 and 11.1, I put these together because the calculations are pretty much identical. It's just a different way to ask the question. So I put them together that way you can kind of see the similarities and put them together as far as, in your mind, as calculations. Okay, so we can combine the concepts of molarity and stoichiometry. That's what we're going to do. So stoichiometry, all that means is that we were looking at stoichiometric amounts, meaning we were looking at, we had 1 mole to 2 moles, or 3 to 2. And we were calculating our grams to moles to grams. Okay, that's what stoichiometry means. You're looking at those mole to mole ratios. So now we can combine molarity and stoichiometry and determine the relative amounts of reactants and products involved in reactions in solution. Okay, so that's the main key here. So we're looking at solutions now instead of just solids. Okay, so molarity is equal to the moles of solute over the liters of the solution. So you see it written as molarity is moles over liters, or you can use millimoles and milliliters. Okay, so a millimole is 1/1000th of a mole. And it comes in handy when you have small quantities because you'd rather be looking at 21 milliliters versus 0.021 liters. That would make more sense to look at it that way in the lab. Okay, so this slide, I think it's the identical one, or close to it. Okay, so one of the main reasons that molarity is so commonly used is because we can rearrange the equation and we can solve for moles. Okay, so if we rearrange molarity equals moles over liters, I think you may have had to even do this one on the exam, you get molarity times liters equals moles. Okay, this can also be written as molarity times milliliters, except for you're going to get millimoles instead of moles there. Okay, and you can also rearrange to solve for liters, so moles divided by molarity. So if you need to take the time, a lot of you are good with your algebra and that kind of thing and rearranging, but be sure that you see that. So molarity equals moles over liters, we can rearrange into these two equations there. Okay, so what we're going to do, we're just going to start out practicing. So we're going to walk through this step by step. Okay, and you're going to see the similarities from what we've already been doing, hopefully assuming that you understand what we did last unit. So some of you did not, but we're going to walk through this step by step. So what we're given here, so this first one's a real easy one. This one's just to remind you and for you guys to understand how to rearrange. So actually going to let you guys work this one out. So this would be like one that you would have had on the last exam. Okay, so I want you to find moles, and you're given a volume and a molarity. Okay, so it should be just a one-step, easy expression here. So we're not given a reaction here, so it's just kind of a one-step. We're finding moles of sulfuric acid. Okay, so we're going to start this one. How are we going to rearrange to find what we're looking for here? Okay, you can do that if you would like. So instead he turned milliliters into liters, so we move our decimal place back. Okay. All right, so moles equals okay, so what did you guys end up getting? Okay, 0.162 moles of our sulfuric acid. Okay, so easy enough. We just rearrange, multiply our molarity times liters. Had you kept this in milliliters, then your answer would have been in millimoles. Okay, so a lot of my students, they don't like millimoles for whatever reason, so they just convert everything to liters and just use it that way, and that's fine. So either way that you want to do that. Okay, now I want everybody to take a second to read this, and I want read the problem and try to think about where you would start. Where would you start with this problem? that was a good thought. But it is balanced. But yes, you want to be sure it's balanced. Okay, it's a 1-to-1 to 1. Okay, so what are we looking for here? Okay, we're looking for volume, right? Of sulfuric acid, so that's right here. Okay. All right, and we're given a molarity, so we're given the concentration of the sulfuric acid, but we want to know, so in the lab, this would be useful. So I know the molarity, and I know that I have 2.792 grams of my other reactant, but I want to know what volume. So that doesn't really tell me much. I may know the molarity of that acid, but I need to know how much. So what volume do I need to use to react with the grams that I have of the sodium carbonate? Okay, so we're looking for volume. So this is different, right? Because previously you've just been solving for either grams or for moles, right? Okay, so where do you think we're going to start? Because I always say start with what you're given, right? Well, you're given two things. So what do you think would be the most likely thing to start with? Exactly, okay, because we're given grams of our sodium carbonate, okay, but we want to find the volume of sulfuric acid. So the key here is we're going from one quantity to another one, just like we did in Chapter 3. Okay, so we're going to take our grams. So we have 2.792 grams. Okay, so just like a word of, just kind of a hint here. For these problems, if one of them you're given grams, that's what I would start with, because that's the easiest, just to go from grams to moles. So if you have grams in the problem, that's where I would start. Okay, so we have grams. Okay, and just to be sure everybody remembers this, some people like to wipe everything away after the exam, but we need to convert from grams to moles. Okay, so how do we do that? What do we use? Okay. All right, it's always out of 1 mole when we use the periodic table. All right, so I want you guys to add up your molar mass. Some of you guys on the exam, I think you just assumed you knew how to do it and didn't practice as much with this, so be sure you know how to add up the molar mass here. Ultimately, what we're going to do okay, I rounded up. I just rounded to 106.0. Is that about what you guys, or 105.99? Okay, so this is what we're doing. We're going from grams to moles of what we know. Are known. Okay. All right, so what is going to be our common relationship? How are we going to get from units of sodium carbonate to units of sulfuric acid? Balanced equation. So the same thing from last exam, right? Okay, so if we look here, this step is kind of going to show it anyways, even though we have a 1-to-1 to 1 to 1 to 1 here. Okay, that's not always going to be the case. Okay, but we do have a 1-to-1, so we have 1 mole for every 1 mole sulfuric acid. Okay, so it's an understood 1 out in front of these. Okay, so our grams cancel. Okay, so if this problem asks for grams of sulfuric acid, then we would just convert from moles to grams, right? But we're asked for volume. Okay, so the only thing that can be plugged in here is this molarity. So I encourage, some people see this right away, but I would say that these problems we're doing today is probably some of the most missed problems on the next exam as well as the final. I don't know what it is, if it's just seeing the molarity and and plugging it in. So I would encourage you, whenever you see molarity, you see uppercase M, to go ahead and write out moles over liters. Because that's what the definition is, that's what its units are, and that's how it's going to be plugged into your equation. Okay. Okay, so here we have, so if we just write it out, so molarity is the same as moles per liter. So if we go like so, instead of writing out molarity, we can write it like this. Okay. Key here is that we have this liters as a unit. So that means we want this left on top, not canceled out, because we're trying to find volume, right? We're trying to find volume in liters. Okay, so what we're going to do here is we're going to plug in. We need moles. So we have 0.324. And this is understood to be 1 liter there. And 1 liter. Okay, so we just flipped it over to insert it into our equation here. Does everybody see how I did that? Okay. And the reason the moles is in the denominator is because we have to have our moles, our units cancel every step that we take. Okay, so when we cancel the moles, we're left with liters of sulfuric acid on top. If we go back to our equation, that's what we're asked to find. Okay. And so then we just do the calculation. So we take our 2.792, divide it by 106 and by 0.324. I'm going to give you guys a second to do this. Some of you also did this part right, so you got a lot of credit on the last exam, but then you didn't punch it in your calculator correctly or somewhere had some calculator issues. So I encourage you to bring your calculator. Be sure you get the same thing that we do in class. Anybody have an answer yet? What'd you say, Jennifer? 0.08? Okay. I think I got, let's see. I got 1.3, 1.2. That's the same thing. Okay? Okay, so if you were asked for milliliters, so say it was question or multiple choice and it says in milliliters, you can solve for liters, obviously, and then if it's asked for milliliters, then you just move your decimal place over 3 places. So if we were asked for milliliters here, we would have 81.3 milliliters, which would actually be more useful. I can measure more precisely 81 milliliters versus 0.08 liters. So this one would be more useful. Yeah, it depends on, actually asked for liters here, so you just leave it as liters. Questions? Yes. Yeah, this everything on top is times 1, so you would just divide by 106.0 and then divide by 0.324. Yes. Good question. This is what gets everybody. Molarity is equal to moles per liter, right? Okay, so its units can be written as big M, which is what you normally see, or you can write the units as moles per liter because that's what molarity is. It's moles over liters. So when we plug it in here, we're actually looking at it as moles per liter. Okay, and here it's just flip-flopped, so you can write it, either way, depending on what you need to do. Yes.
So, ask you volume, your steps are going to be grams to moles.
Yes, for this problem. Okay, we're going to see there's, these vary. So the next problem, I believe, we may be starting with molarity, or we may be starting, so we'll see different. But if you're given grams and you're asked for liters, and you're going to go from grams to moles to liters. Yep. Okay, so this one is a little bit different. Okay, so I want you to again take a couple seconds to read through this and then think about where you would start with this problem. Okay, this one's a little bit harder than the previous problem. Any ideas? Okay, very good. He sees it right off. That's great. Anybody else see that? Okay, so earlier on the previous problem, to get to moles, we went from grams to moles because that's what we know, that's what we've been doing, and we know that we can do that by using the molar mass. Okay, here, so this is another way to kind of know where to start, okay, because if you can get started, usually things can go well from there, but it's kind of seeing where to start. So previous problem, start with grams. If you're given grams, that's where your starting point is going to be. Okay, for these, the starting point is going to be from what you know the most about. Okay, so you're obviously trying to find the NaOH, and you know its molarity, so that's going to be later. You're going to find that at the very end. Okay, so whatever you're trying to find and whatever you're given for that compound is going to be used later. Okay, but you want to look for what you know the most about. So we are given a volume and a molarity for sulfuric acid. Okay, that's going to be your starting point. Okay, so it's not just like I used to say, write down what you know. Well, here you've got to find what you know the most about. Okay, so you take those values. Okay, this step is exactly what Anderson just said. So earlier we went from grams to moles, and now we aren't given grams. Okay, so we still need to get from our units we're given here to moles so that we can use our balance equation to get to moles of what we're trying to find. Okay, so what we're going to do is so everybody remember this is why it's so important. Okay, if we rearrange, molarity is equal to moles per liter. If we rearrange to solve for moles, what do we get? What would be it's the very first problem we did. If we rearrange, molarity times liters equals moles. Okay, so that's exactly what you're going to do here. You're going to take your molarity, okay, and you're going to take your liters, and you're going to find moles. So let's write it this way, liters times moles. Okay, so I'm going to write out my liters so we can convert to liters. Okay. Okay, we're still going to keep it in that sequence where everything cancels out and we see, why we get to that end unit. Okay, but the key is to remember this first step, all it is taking liters times the molarity to give you moles. Okay, so what we do here is we plug in. So we're given this 0.505. Okay, so which way do you think we're going to plug this in? Are we going to have liters in the denominator, or we're going to have moles in the denominator? Exactly. Okay, so we have liters, so molarity, so let's write this out, is equal to moles over liters. Okay, so you're going to plug this number in because molarity is the same thing as moles per liter. So you just plug this in to here. Okay, does everybody see this? Sometimes it's hard to see. Molarity is equal to moles per liter. So moles per liter. That's the same thing. So all you're doing is taking liters times molarity. Okay, but you want to plug it in as moles over liters. That way you see how your units cancel, because the next step is going to be to look at our balanced equation and go from moles of sulfuric acid to moles of what we're trying to find. Okay. Okay, so we're trying to find the volume of NaOH. Okay, so now we're going to go look at our balanced equation, and we have a 1 to 2 ratio. Okay, so we have 1 . Okay, so we have one step left. Okay, in this last step, we're looking for volume, just like we were on the last slide. Okay, so I want you guys to think about what are we going to plug in here in the last step. Okay, so if we look back up here at our molarity, that's the same thing as moles per liter. Okay, so we just do exactly what we did on the previous slide. We plug that in. Okay, so it's just kind of inverted here. So either one of these you can use, liters or moles. So we plug in our 0.505 and 1 liter. So plug that in your calculator and see what you come up with. Okay, so 0.0800 is what I'm hearing. Okay, and how many milliliters is that? That was going to happen, sorry. Okay, there we go. Okay, any questions? Okay, this one's probably the hardest one so far. Okay, so we're given 2 molarities, we're given a volume. We start with what we know the most about, so we take our volume times the molarity to give us moles. Okay, so that's all we're doing in this first step is this right here. Okay, then we use our mole-to-mole ratio, and then the last step is to find the volume, so we plug in our molarity again. So the key thing is to see that molarity is equal to moles per liter, and you just plug it in as that instead of plugging it in as molarity, so that you see that your units cancel. Okay, but these take practice. So that's why we're going to look at another example and show how it's used in the laboratory, and then we're going to just work problems. So that will be what we do the rest of the time. Okay, from section 11.1, it talks about acid-base reactions. We don't actually get into talking about these until Chem 2, and we're actually doing that right now in my Chem 2 class. But there is one kind of definition that I like for you guys to know and at least hear before you get to Chem 2, is the neutralization reaction. So this means that an acid and a base, okay, react to form a salt plus water. Okay, so that means it's basically you're neutralizing your acid with a base to form a neutral salt and water. And so you guys are actually, the next unit, we're going to look at what's called titration. So we'll be doing this a lot in the lab. We do this day in and day out. So a lot of times to save, Janice and I, to save, waste and from putting out all these acids, we will titrate it. So we'll have maybe, if we have a strong acid or we have an acid, we'll just neutralize it, and that way it can go down the drain instead of having to be, put into containers and then be taken off by whoever else. So we'll just neutralize it, salt and water, and it can go down the drain. So when you guys are doing a titration, I'm going ahead and using that word because you'll be seeing it a lot here soon. We do this too. So once you neutralize your acid, then it can go down the drain. So we don't have to, saves us on having to have space for all of the solutions to be put into. So an example, very common example is if you have a strong acid, so hydrochloric acid, hopefully you guys have heard of that. That's what's in our stomachs, our stomach acid. Okay, and sodium hydroxide is another, it's a strong base. And when these react together, they form salt, so table salt, NaCl, and water. Okay, so we can do the same type calculation for neutralization reactions. So that's why I put these together, because all it says differently here, it says to completely neutralize. Okay, but we're given the same types of starting points. We're given the molarity, we're given volume, and all that. And so we're doing the same calculation. Okay, so for neutralization reactions, this is the calculation that we use, okay, to solve for the volume or whatever we're trying to find. Okay, so here we're asked to find the volume of NaOH, so we know that's going to be our end point. So we're not going to use that 0.750 till the end. Okay, but we're going to neutralize 100 milliliters of 0.250 phosphoric acid. Okay, so we're given the most information here about the phosphoric acid. Okay, so this is set up exactly like we just did on the previous problem. Okay, so we take our liters, so we can convert to liters here, so move our decimal place back. Okay, so we have 0.100 liters. Okay, so remember that liters times molarity equals moles. Okay, and so that's all we're doing in this step, except for molarity is being plugged in as moles over liters. Okay, so we have this 0.250 molarity, or moles per liter. Okay, so this is being plugged in here. So we have our liters now cancel. Okay. Does everybody see this first step where I got the 0.250 from? Yes? No? Okay. All right. Now we have moles of our phosphoric acid, but we're trying to find volume of NaOH. So we know if we're going from one compound to a different one, we have to use the balanced equation. Okay, so we plug in, so phosphoric acid's in our numerator here, so it's got to be in the denominator here. So we have 1 mole in our problem, and we have 3 moles of NaOH. So we have a 3-to-1 mole-to-mole ratio. Okay, so now we can cancel our moles. Okay, we have to have moles in the denominator in the last step. Okay, and so now all we do is we take our 0.750 moles per liter. So that's the definition of molarity there. And we plug it in, moles per liter. So we're left with liters on top. And you do the math. You multiply 0.10 times 0.25 times 3 and divide it by 0.750. You should get 0.100 liters of NaOH. Okay, so that's the amount or the volume of NaOH that it would take to neutralize the acid. So if we have 100 mils of acid and it's 0.250 molarity, it's going to take us 100 milliliters or 0.100 liters to neutralize it, to form. So if we look back here, neutralize means to form a salt plus water. Okay, so that's how much we're going to have to use to form the salt plus water, to neutralize the acid. I think I had this was 115. I did this. They didn't even send me a new version of this book. I don't know why they even update them because they're the exact same thing. But they're on page 111, so 78 through 81. So I want you to start working these, ask questions. come across any issues, let me know. I'll come around and then we'll work these, okay? If you do not have a book, look around you, try to find somebody that you can share or at least write down the problem. Yeah, I meant to send an announcement to remind you guys to bring your books, but here, y'all want to copy them down? Yep, you're welcome. Starts right there. Does anybody else need? Can you share with him? At least just write the problems down. Andrew, Cody, did you come in? I got you. Jake. China. Wesley. Sujal. Jacob Young. Justin Anderson, Alex, Jesse Davis, Jordan Elledge, Daniel Lee, Joey, David, Jennifer, Taylor Thompson, okay, so number 78, you're given grams, so that's a automatic good place to start there. These are actually part of your homework problems, so we're doing them in class, so everybody should have these come homework time, hopefully. getting something similar to this? Okay. So you're given grams, so the first thing is convert from grams to moles. Okay. If you look at the equation, so it's already balanced for you. We have a 1-to-1 ratio. Okay, so the only difference in this and from last unit is we're plugging in the molarity. So the molarity is 0.157. So the molarity is the same thing as moles per liter. So we're plugging that in here. Okay, so what were you guys getting here? Okay, I got about, okay, but it may be just a little bit different depending on your molar mass. Okay, should be about 40.9. All right, go ahead and work 79. Keep going with them. I just wanted to get you started with that one. Yes. Mm-hmm. Where are you getting 3 from? Yes, it's just how it's written, it's how it's drawn. So you have 2 carbons, so you have 12.01 times 2. You have 2 oxygens times 2, and then you have 4 hydrogens.
Okay, that's where.
So I don't know, you don't need that, I don't know, whatever, yeah. Yeah, you just take the atoms that are in just that. You don't look at anything else, yeah. Because your units, that may be what you're, yeah, 0.385 grams of acetic acid. So you need to write out, see how I write out my units there? Exactly. That way you don't get confused and try to add them up. Oh, that's good. So you got 1.149, let me see. Yep, so I just rounded up to 1.15. Okay, so this one's a little different because we're being asked for grams. Okay, so the last step is just going to be going from moles to grams. So it's going to be the same as we've been doing. Okay, so we have to take our molarity and our liters. just going to go ahead and convert to liters because that's what most students like to do. Okay, so liters times molarity. So the first step is we're going from liters to moles. Then we're going to go to moles. Then we're going to go to grams. Okay, does everybody see how I did the first step? Molarity times liters. Okay, now we use our balanced equation. So we have 2 moles KOH for every 1 mole CO2. Okay? And then this time we're not asked for volume, right? We're just asked for grams. So what do you think we're going to do here? Okay, it's going to be out of 1 mole, right? On the bottom. And then when we add up the molar mass, we get about 44.01 grams. So the last step is just our typical moles to grams. So we get about 1.15 grams, or you could have kept your 4 significant digits if you wanted to. So 1.46 or whatever somebody got there. Grams CO2. Did anybody get this before I put it up here? Perfect. All right, work 80 and 81, and then we'll do those up here as well. You guys gotten this far yet? Y'all need a couple minutes? Almost. That part goes with the moles, and then it's out of 1 liter. So just swap it up. Yeah, that goes on the bottom. Okay, Okay, so we're given the molarity and the volume again. Okay, so I'm going to do this one in milliliters just so you guys can see the difference here. So if we're given so your molarity here can either be moles per liter or millimoles per milliliter. Okay, so we would plug in 1 milliliter. You can convert to liters if you want to, or you can do it this way. I'm just showing with millimoles just to show you. It's the same thing. It's just going to give your answer in milliliters. Okay, and you do not have to. This is where students accidentally make a mistake here, because this here we can consider our ratios. Okay, these numbers can be moles or millimoles. You don't move a decimal or anything, so it's really just the same idea. So we have 1 millimole now of Ba, of barium hydroxide, and then we have 2 millimoles. Okay, so we're just using those same numbers here. Moles of nitric acid. Okay, and then we plug in our molarity again. So same idea, you don't have to move decimals or anything like that, and you're just going to get your answer in milliliters, so you would get 8.41 milliliters. Okay, and what we'll do, we'll pick up with 81, that way you can work it, and that way that'll kind of be a starter for Wednesday to refresh everybody on what we did today. So go ahead and work it. I mean, you can check your answer if you want to before you leave, but we'll pick up with that one. If you want to see your exam, you're welcome to stay right now and look at it, but I will need it back. So, but you guys have a good afternoon.